Hello everyone, and welcome to this lecture on the map function. So map is a built-in function in Python. It's going to be one of the first built-in functions we work with. And it's a really useful function, especially when you use it in conjunction with a lambda expression. And we'll go into that a little further. So map comes in the form map, and then it takes in two arguments, a function and a sequence iterable, such as a list. And what it does, it applies this function to every element in this sequence, and then returns a new list with the elements changed by the function. So let's go ahead and see what this looks like in a live coding example. If you remember from the list comprehension lectures, we used list comprehension to convert temperatures, right? Fahrenheit to Celsius. So let's go ahead and see what that looks like with map. So I'm going to use map. I'm going to create a function called Fahrenheit. And it's going to take in a temperature that's in Celsius, and it's going to return the temperature in Fahrenheit. So it's going to return the temperature in Celsius, and that equation looks like this. You may remember it from the list comprehension tutorials. So here we have our Fahrenheit function. It takes in the temperature and then returns temperature in Fahrenheit. So to give you an example, let's go ahead and look at Fahrenheit of 0 degrees Celsius is 32 degrees, right? The temperature where water freezes. Okay, so what if I had a list of temperatures in Celsius? So I could say, let's say 0, that's like room temperature, and then let's see, boiling water at 100 degrees Celsius. So what if I wanted to apply this function to every element in my temperature list? That's where map comes in. So I'm going to say map, the name of my function, Fahrenheit. And notice I'm not actually passing any parentheses. I'm just passing the name of my function. So I don't do this. It's just the name of the function. And then I pass in the sequence iterable, in this case my list. And what I get is every element in that list with the Fahrenheit function applied to it. Great. So in this example, we could have used a lambda expression, so we didn't have to actually define this whole Fahrenheit. So this is great when you want to do some sort of anonymous function call. So you don't want to have to define an entire function, so you use a lambda expression. And I mentioned before when we were covering lambda expressions that they would be really useful with map and filter and reduce. So now we're going to see them in their true action. So I'm going to say lambda, take in some t, multiply it by 9 divided by 5, and I'm using 9.0 so I don't get any floating point errors, I don't get any cutoffs. If you're using Python 3, you didn't have to worry about that. And that's my lambda expression. And now I'm going to apply it to my list, and we get the exact same result. Awesome. So now I actually, with map, don't even have to define an entire function name and call it. I can just use a lambda expression instead. And usually when you see map in someone else's code, it's almost always using a lambda expression. Okay, so how can we build on top of this? So if you remember, lambda expressions can actually take in multiple arguments. So I could have something like lambda xy return x plus y. So I can have that sort of lambda function. And we can incorporate that with map. So we actually can pass more than one sequence iterable, and I'll show you what I mean by that. I'm going to create two lists, actually three, 1, 2, A, B, and C. So let's go, A is going to have 1, 2, 3, B will have 4, 5, 6, and C will have 7, 8, 9. Okay, so I have A, B, C, and now what I'm going to do is map the lambda expression I had, which takes in two arguments, x and y, and then returns x and y added together. But remember, I'm going to take in two arguments now, a and b. So what map is going to do is it's going to be able to work with two or more sequence iterables. So it's going to apply this lambda function in order. So it's going to take the 0 index of A, 0 index of B, apply this lambda expression. then the one index of A, one index of B, apply this lambda expression and continually do that. So if we see the result, we basically get A plus B. So 1 plus 4, 2 plus 5, and 3 plus 6, 5, 7, 9. And we can actually extend this further to even more than 2. So I could say, let me put a space in here so it's really clear, x, y, z plus z input A, B, C. And you'll notice now we get 1 plus 4 plus 7, 2 plus 5 plus 8, 3 plus 6 plus 9. Usually you won't see something or map and lambda expressions used for this many sequence iterables. At least it's not too common from my own coding experience. But it is used sometimes if it's the right tool in that case. So maybe you would want to perhaps change these variables if it's more clear for you to see it this way. Although it may be unclear because it may think you're referencing those lists themselves, but you will get the exact same result. Okay, so let's go ahead and do one more example to really drive the point home of what map is doing. Let's go ahead and make an example that creates the, let's say, times every number in a list by -1. So I want to map some lambda expression, and the lambda is going to take in a number and return that number times -1, and I'm going to apply that to my A list. And there you have it, -1, -2, -3. So map, its idea is actually pretty simple. You put in a function, remember it's a function name, you don't actually pass in the parentheses, and then you pass in some sequence iterable like a list. And then it returns a list of that function applied to every element in that sequence. And that's really all there is to map. And it's super useful when you use it in conjunction with lambda. Alright, so go ahead and read over the other examples in the Jupyter notebook that we have here, and make sure you understand map before continuing on to the other built-in function lectures. Alright, thanks everyone, and I'll see you at the next lecture.